Hey guys, Sebastian from Madrigal here. This is Traction Point. It's a game I'm building using my own game engine and tools, a game engine called Basis. Today I want to talk about NVRHI, or the NVIDIA rendering hardware interface. Because for the past maybe 2.5 weeks, I've been living and breathing NVRHI. But quite often, not always, quite often when I talk about it, people are like, what? What is that? Even though I feel like a lot of developers, especially smaller indie developers, could benefit a lot from at least knowing about NVRHI. So let's talk about it. But first, a little bit of background. So about 2 years ago, I made a video about web GPU. And in that video, I talk about specifically using web GPU in the context of native games. So basically as an abstraction layer over the native graphics APIs, your Vulkans, DirectXs, Metals, etc. And I mentioned that I like the web GPU API a lot. And I like the fact that it allows me to target the modern graphics APIs, let's say Vulkan, because I might want to use modern profiling tools, for example. And it also allows me to target several of those modern graphics APIs with a single common API abstraction layer. However, there were certain things I didn't quite like about web GPU in the end, such as their custom shading language. Also, building some of those backends can be a little fiddly. So in the end, it didn't really work out for me. I might still use it in some web environments, web cases, but for Basis, for my game engine Basis, it didn't really work out, and so I basically fell back to D3D11. And since then I've essentially been looking for a replacement for that. So essentially what I would like to have is an API that allows me to work on roughly the D3D11 level of complexity, while still targeting the new ones, the new modern APIs. And I think I found that in NVRHI. So let's take a look. We can go here to the GitHub page, and we can see that it is licensed under the MIT license. This thing is made by people working for NVIDIA, but it doesn't lock you into using only NVIDIA GPUs or anything like that. It does work on AMD. As far as I know, it does work on Intel as well. And so what is this? Well, I'm gonna put a link to this article below in the description, but just quickly take a look here. It's a library that implements a common abstraction layer over D3D11, 12, and Vulkan. And it does some things like managing the resource states and barriers, tracks the lifetime, these things that essentially do what I just listed I would want to have, right? As a bonus, it also does things that web GPU doesn't really do, as far as I know. It supports ray tracing, supports meshlets. It also supports bindless rendering and other fancy new things that admittedly I don't use yet, but it's nice to have the option, right? NVRHI also doesn't really do any mangling of your shader data or put any sort of requirements on how you need to bind things, stuff like that. It basically just expects you to have your shaders in whatever the actual backend requires of you. So that's really nice. So NVRHI at least ostensibly solves all of these issues that I've been having, or these sort of wish list features that I've been wishing for. So what did I have before? Well, I had my own RHI, or render hardware interface, called GFX API. And I made a bunch of backends for it, actually. For example, on the channel, there's a full video series where I write a Vulkan backend for GFX API for Basis, using the VEZ library. So do check that out if you want to. It's quite old, and it didn't really work out in the end either. But that may just be like a skill issue on my part rather than anything else. But I've had a common abstraction layer already in the engine. And so basically replacing it with NVRHI meant that I had to go through and basically rip that out. But I didn't remove it completely, and that is important. We'll talk about it a little bit later. Initially, I thought I would make NVRHI sort of like a backend for my own RHI, the GFX API stuff. But then I figured, I think the NVIDIA guys are probably better than me at making an abstraction layer. So I quite simply just ripped out the parts that were conflicting and replaced it with NVRHI, just straight up. So let's see what we have. This is all now running on NVRHI. This is Traction Point. This is the game that I'm currently working on. If you join the Discord, you can play this, or you can play a slightly older version of this, which admittedly doesn't run on NVRHI, but soon you will be able to play the NVRHI version as well. Now, this is running on D3D11. D3D11 is still my sort of main graphics API backend, if you will. Since I've only spent a few weeks doing this stuff. For example, I haven't touched the shaders at all. They're exactly the same, except for perhaps like a binding or two that I changed. But this is the game running. Looks exactly like before. At least I haven't been able to spot any differences or artifacts or anything. Works exactly like before. Everything is good. We're sitting at a locked 75 frames per second now, because that happens to be the VSync for this monitor currently, but it runs at about 150 or so on my measly 2060 GTX that I have in this computer. Right, so after the 2.5 weeks, the D3D11 version has full feature parity with the old version, but as a goof, I actually just tried writing a D3D12 backend on stream. You can find that stream on the channel. It's one of the more recent streams. I'll put a link to that as well in the description below. And while the outcome of that stream was a little buggy, you can actually see that we can quite happily now run the game in D3D12 mode as well. So here's the same thing running in D3D12. I think the loading is slightly longer on D3D12. But I fixed all the issues that we had in that stream. Now runs quite happily with this as well. Worth mentioning that I actually mentioned it previously, but I haven't touched the shaders at all. So this is still DXBC shaders, so D3D11 style shaders. I haven't touched them up for D3D12 at all, but at least now I have the option to go and convert them to DXIL or even SPUR-V, which is supposedly where DirectX is heading in the future. So pretty cool. There are a few caveats though. The editors currently don't really work with D3D12. I need to fix that up. And it also became kind of evident quite fast that I can't do the high-level rendering quite the same way on D3D12 as I can on D3D11. Let me demonstrate. If we resize the window a few times, we get an error. Error, failed to grow a descriptor heap. And that basically has to do with how I generate bindings, and also how that conflicts with how NVRHI generates bindings. So basically, if I do enough bindings the basis way, we're going to run out of descriptor heap memory, and that's something that I quite simply just have to fix on the high level rendering side. But I have a plan for that. I just haven't gotten around to doing that yet. But I'm still kind of amazed that it just works this well. Not amazed with my own stuff, but amazed with NVRHI and just how well it kind of translates the old concepts that I'm sort of very used to working with, and the way that that basis is architected. And it runs this well on D3D12 as well. That's pretty awesome. We can look at the editor side. As I mentioned, the editor is a little buggy with the D3D12 currently, so I'm defaulting to D3D11. But again, this is another level that I'm currently actually working on. Trying out a slightly different art style here for the cliffs. As you can see, this is very much white box still. We have some completely in progress parts here. But again, renders everything, renders these thumbnails on the fly, everything works. NVRHI, ladies and gentlemen. Super easy to work with. Very cool. Finally, before we look at the code, just as an added little fun thing, I have an older game project called Project Slide, which also uses the same game engine as Traction Point. This is the game that I actually showed off in the web GPU video, right? It hasn't progressed since then because I'm not really working on this game currently. But here you can see, not a single line of code was changed, and this is also running on NVRHI. Admittedly, D3D11, we get that same heap descriptor heap out of memory situation in Slide, and we actually get it even quicker than in Traction Point because there tends to be more stuff in the Slide levels. But it runs really, really well here as well. Kind of just amazed at how well NVRHI sort of bridges the gap between D3D11 and 12 here. Super awesome. And I might add, it runs much better than WebGPU ever did, even though WebGPU did run pretty well as well. All right. So let's look at the code. I'm gonna do like a side-by-side comparison here of something that this is like the full screen effects CPP file, and I have a diff here. This just contains a whole bunch of full screen effects that the games use. Not all of them, but some of them. And essentially give you an idea of the kind of work that I had to do to convert to NVRHI. So since my own GFX API is not necessarily going away completely, but a lot of it is going away, you can see that we have removed, this is the old one, here on the left, this is the new one, here on the right. We have a lot of these things like textures, buffers, render devices, render contexts, samplers, and so on. These are gone, and they're replaced with the NVRHI things. And so essentially the work has been doing pretty much the same thing just many times. Previously where we had a render context, now we have a command list. It comes from the NVRHI namespace. Where we have a buffer, or where we had a buffer, GFX API buffer, now we have an NVRHI buffer instead. And where we did context write to buffer, now we do command list write buffer. So actually I kind of lucked out in the sense that the APIs were kind of similar in many ways, right? Here's something kind of interesting. Copy texture effect. So this is hardly a full screen effect, but it's kind of using the full screen effect framework here. It quite simply just takes an effect and copies it to another one. So I mentioned previously that I didn't get rid of the GFX API stuff completely. Here we are creating the PSO, or the pipeline state object. So we're collecting all the shaders, all the state for how we want to render something, and we're creating something called a PSO out of that. Previously, we just got a GFX API pipeline state description. We set the shader on it, set the uniforms, so shader inputs essentially, and then we created a pipeline state. I'm still actually doing that, and I'm doing this the thing with the same type, the GFX API type here. I just also have an NVRHI type. Now, arguably, this is kind of silly. I've just sort of mechanically done it for everything here. But it's a little silly to actually create it in the GFX API version and then convert it using a conversion function to the NVRHI one. But in certain cases, it can be really handy because this GFX pipeline state description, this is something that we can look at here. For example, if we have a material resource. So this is essentially like a data file that we read from the disk. If you've been following me for a while, you know that I have this shader editor thingy here. This is like a grass material, for example. This generates code based on this node graph and writes this to the disk along with all of the render pass properties. So, the depth right tests, fill modes, cull modes, all of that stuff. And so we have a material description, which in turn contains one of these pipeline state description types, which is serializable. All of this to say that we can actually just load one of these GFX API guys from the disk or from over the network or whatever, where you get your serialized stuff, and then convert it into NVRHI form. I do a few more steps here. I create an input layout automatically from my shader format, which hasn't changed at all. Compare this to something like WebGPU or even just adding Vulkan for the first time. NVRHI kind of just like eats what you give it, and so far it's been working really well. Adding the layout, so that's basically like the inputs, shader inputs, and then we're creating a BSO. So you can see that we're essentially doing the same thing as here. You might be wondering why I'm doing like a detach here. So NVRHI likes to work with something called handles, and they are essentially like ref-counted smart pointers. I have in the past been very explicit about my reference counting. So previously where I did release and null, now I do the same thing with the PSO. And because of that, I just do a detach here, and then I can work with it exactly the same way as I used previously. But like new code will most likely use their smart pointer things. Another thing that has changed a little bit with NVRHI is that we now use command lists for basically everything. So here is a piece of code that we use to load textures from DDS files, to texture resources, essentially. I'm going to show you where you can get actually this DDS loading code in just a second if you want to use NVRHI and you don't want to write this yourself. To be able to load a texture and initialize it with data, you can't give it just initial data like you used to be able to do with D3D and even WebGPU before. You need to give it a command list. And you can see here that you're creating a texture, we're filling in the texture description, much like you do in D3D11. We're creating a texture. You can see one of these texture handles that I just spoke about. But then you need to actually use a command list, so execute commands on the GPU to be able to fill it with something. Otherwise, it's going to be essentially undefined what it contains. And here you can see a little bit of this automatic state tracking and actually overriding that when you know that something is going to be in a particular state. So here we're loading a texture from a resource, and we know that texture is going to be used as an input to a shader, so shader resource essentially. We can let NVRHI know that, hey, we're beginning an operation here, and we want the resource state of this texture to be common. Then we iterate over all the array slices and the MIP levels, and we write the data to the texture that we've gotten out of the DDS stuff. After that, we set a permanent texture state to be shader resource. So unless you go and change this later on, NVRHI won't have any overhead in trying to track different usage states with this texture, because it's essentially only going to be read from. So NVRHI allows you to do this if you know that you're only ever going to be using the texture or a buffer or some other resource in a particular way, which is really nice. It doesn't just assume that it always should take care of a texture. However, if you want to have a texture that you can, for example, render into, so here we have the FXAA effect, and it has something called a tone map luma texture, which we will both use as a render target and later on read from. We can specify here in the texture description that, well, first of all, it is a render target, and the initial state of it is indeed render target. But we can just set it to keep the initial state, and that means that whenever we start executing a command list, we assume that the state is going to be this render target state. So keep initial state and initial state. And if the graphics pipeline requires any changes to be made, for example, when you later sample that texture, you can have NVRHI actually make that resource transition, add a barrier there for you automatically. So super handy. This is not a texture that we know is always going to be used in a certain way. And we're basically asking NVRHI to track that for us by specifying, hey, keep the initial state, and then we tell it what is the initial state. So super handy. All right. One last piece of niceness that I want to show you here in this code is, if we go to the game, actually let's go to traction point. I think that's probably a better way to show this off. So traction point uses HBAO+, another library that comes from NVIDIA, but it's actually not using NVRHI. It's using just straight up D3D11, and it also comes with D3D12 implementation. So SSAO, you can see if I toggle it on and off here, especially here on the cliffs and maybe even underneath the car, you can see quite a bit of change, right? So how would you integrate something like this into a game if you're using NVRHI? And this is one of my sort of, well, I don't know necessarily favorite, but a feature of NVRHI that I like a lot. And that is the ability to just get the native objects out of an NVRHI object. So here we have, this is now native D3D11 code. This is something that I've implemented on the backend side. So the D3D11 backend has one version of this, and the D3D12 backend has another version of this. Render AO, and it gets an input depth texture that we want to sample. And so how do we do that? How do we give it a shader resource view when it expects it as a raw D3D11 one? Well, you can quite simply, out of an NVRHI texture, get the native object, like this. And here you can see this is the native D3D11 object, which you can then, do whatever you want. I had some issues here. You can read the comment if you're really interested in what I had to do. But basically then I write a piece of native D3D11 code before we actually then pass it to the HBAO plus context. And this is then forwarded to the NVIDIA internal library, which just expects a straight D3D11 object. So super easy way to get it. We can look at the D3D12 version, works basically the same. Again, we have an input depth texture. This interface here looks exactly the same because this comes from the sort of high-level renderer of the game engine. And again, we have an input depth texture, and again, we can get the native D3D12 resource out of that. And from that, you can then do, if you've done any D3D12 code, this should look basically similar or familiar to you. We create a shader resource view into a heap, essentially, that we then give to the HBAO plus library. And this just works. It's remarkably easy. So we get both the D3D12 graphics command list and the D3D12 resource out of the objects that we've passed from NVRHI. And it just works. The thing that NVRHI doesn't give you is a so-called device manager. And this is where I want to start mentioning another excellent library that NVIDIA provides. Let's have a very, very quick look here. If we go to, where is the thing? It is in the tutorial, I think. So NVRHI has a tutorial and it has a programming guide, which is a slightly longer version of that. And it says here that, let's see. Yes, if you're working with the swap chains, you need to add explicit synchronization on D312 and Vulkan. This is probably familiar to you if you work with any of the more recent graphics APIs. It's out of the scope of this article, and working implementations can be found in Donut. So what is Donut? Donut is another MIT licensed piece of code. This is essentially a sample collection. And you can see here that, okay, we have a bunch of different things. We have a feature demo, for example, which is, I think, the only one I really actually ran, which uses NVRHI. And you can see here which one of them are supported on which of the 3 supported backends. But this is an excellent place to find sort of example code of how to use NVRHI. And it is the place where I actually found this DDS texture loading code. I had my previous DDS loading code because I didn't change my texture format, but the Donut implementation just was so clean and nice that I just yoinked that because it's MIT licensed. Donut also has other useful things like MIP generation using compute shaders. You can't typically just take stuff out of Donut because they have their own systems that are sort of, talking to each other, or you're going to have to take a whole lot. But it is an excellent sort of example collection for just like, if you're wondering, hey, how would something be called? You can essentially just look in the Donut samples and you can typically find how something is used, or supposed to be used. So, another thing that is really, really handy if you want to get started with NVRHI is quite simply to download the library from here, from GitHub. Almost all of the interface. Let me just bring this over here to the main screen. So here's the NVRHI library. You can see that it has a base project, which is the sort of common API, and then it has 3 of these backend projects. Now, almost all of the interface is contained here in one long header file, which is super handy because then you can just find something in here. Let's go like those permanent resource states that we talked about previously. We can just go permanent. You can just find, okay, it said permanent texture state. That's actually the one that we called. Things like this. There are some other useful like utility headers here, for example, as well. They can use, but I suggest just like reading through this. It's not that long. You don't have to, remember everything. But it's a really, really good way to get a handle of like how this thing works. If you've been using other APIs and you would like to work with something perhaps a bit easier, perhaps a bit higher level, perhaps a bit lower level. If you're coming from D3D11, this is lower level than D3D11, but just slightly. Or if you would just simply like to have a common API, then I think you will find this quite easy to work with. So that's basically it. So far, I'm super impressed with how well this thing works. While it was a lot of work to actually convert the game engine to use NVRHI, basically everything that I did worked how I expected it to. And so I didn't have to do like a whole bunch of rewrites. Yes, I have that one binding issue on D3D12, but like I wouldn't have, at least I shouldn't have expected D3D12 to work exactly like D3D11 out of the box with this. That would have been almost suspicious. Yeah, I think I've only sort of really scratched the surface of what can be done with NVRHI compared to my old GFX API. I haven't really looked into bindless or ray tracing or any of the other things yet. This just opens up many possibilities. Or indeed, the Vulkan backend might also be a cool thing to be able to support, but that comes later. Anyway, for me, this fills basically everything that I wanted from WebGPU, but kind of didn't really happen for me for native games with that. I'm not saying WebGPU is bad or anything like that. I just think that all the things I thought about it in the context of native games and what it would enable me to do didn't necessarily quite work out. And one final thing with NVRHI, which is really nice, is the fact that it's quite a small library and the code is really well written and easy to understand. If you look at this and you're wondering, okay, so where is like the texture stuff for D3D11, for example? You can just find here like, oh, D3D11 texture, right? Something like this, and you can see here that what we're doing. Create texture. It's right here. It's not convoluted. It's not messy. There perhaps aren't a lot of comments, but there doesn't really need to be because the code is so simple and almost self-explanatory. And we have the same thing for D3D12, D3D12 texture here as well, and we can find create texture here. Here's how we create a D3D12 texture. So super easy, especially if you want to do a little bit of native stuff like integrating into HBA or some other library like that. Might be useful to see what NVRHI is actually doing under the covers. One final thing that is really nice with NVRHI is that it has its own validation. So if you use something like the Vulkan validation layers or the D3D debug layers, there's something called validation here, which you quite simply, you take your device and you wrap it in a validation layer and you get another device. And then you quite simply assign that to your original device pointer. This is as easy as it is to enable the validation in NVRHI. And this gives you a lot of really easy to understand error messages and warnings if you're doing something that might work on D3D11 but will break in D3D12 or Vulkan and so on. It certainly has caught a bunch of mistakes for me. And then you can turn it off if you don't want it on in your production code. Finally, I want to mention a few other things, a few other alternatives to this. If you are looking for a common abstraction layer, but you don't necessarily want to use NVRHI for some reason. I haven't used this myself, but I know of them, and I've heard that they can be pretty good. So the first is Diligent Engine. This has been around for a while. It is supposedly pretty advanced. Apache 2 license. It supports a whole bunch of more backends, OpenGL, Metal, even WebGPU. Has its own common abstraction layer and quite a lot of documentation. So this might be something to look into if you want to check that out. Another one, and something that's kind of recent, is the SDL3 GPU. So SDL3, simple direct media layer, I think is the abbreviation for. SDL3 recently came out, and they now have something similar for wrapping Metal, Vulkan, and D3D12 as well. So this targets specifically the new modern graphics APIs. STL tends to be something that's really sort of well maintained, widely supported, so that's definitely like a plus for this. I have heard that this places this is like a little bit opinionated on how you bind things. So that might be something to at least look into, but especially if you're, if you're making a completely new game or new piece of code that needs to do rendering and you want something cross-platform, this might be a really nice thing to just start working with rather than going, like the OpenGL or D3D11 route. And I'll put links to all of these things in the description below. Finally, I want to invite you to join the Discord if you want to play the game, if this looks cool. And you can play specifically this level in the pre-alpha build, which is available on the Discord server. It's a little rough. There's going to be a much more polished version on Steam soon. But if you'd like to give it a go and give me some feedback, then by all means join the Discord and check out the build that way. If you would like to see how the development of this goes, then by all means do subscribe to the channel. That helps me out a lot. And check out the live streams. I stream semi-often, I should say. Depends a little bit on how the work is going at the moment. But now with the NVRHI stuff out of the way, I have a lot more time to do streaming again. And of course I do videos like this. So if that looks and sounds cool, by all means subscribe, like the video, and I hope to see you in the next one. Have a good one and take care.